In 1949, the University of Chicago completed construction on the Research Institute's building that would house the Enrico Fermi Institute and the James Franck Institute. Today we look back at the people and their work that made the Research Institutes great. And we look forward to the Eckert Research Center and the future of research at the University of Chicago. We welcome you here today to the Research Institute's Cornerstone Unveiling Ceremony.
I came here in earnest in 1952, so that was about 3 years after the cornerstone was laid, and it was still a very new building and only partially occupied.
The first time I came to the Institutes was when I interviewed here, and that was roughly in 1975, and I was very frightened.
So when the research institutes were being considered in the late 1940s, there's actually a document that was put together called Desiderata for a Space to House a Community of Scientists, written by Enrico Fermi's colleagues. And within it, they were asking, what will organic architecture do for the scientist? And there are descriptions of these great organic flowing spaces with lots of natural light and glass and steel to hold the building up. That's actually not what they got. As you know, it's rather flat and economically perfunctory, but functional at the time.
Yeah, the atmosphere was very different in JFI. It was free and easy and kind of relaxed, and you could walk into people's offices and you didn't have to make an appointment, and people were just kind of nice to each other, and that was very obvious right away.
I would of course point to Enrico Fermi and James Franck. I mean, the two institutes that we have, the modern institutes, are named for them, and these of course were pioneers. Everyone knows pioneers of atomic physics, and in particular Fermi ushering in the nuclear age, you know, of course, obviously changed the course of not only the history of science, but history, period. When
I arrived on campus as the newest assistant professor, my boss, Herbert Anderson, took me to an empty room in the Research Institute's building. And he says, okay, here is your lab. We hope you do great work, and if you don't, you won't be here very long. And being a brash young man, that was just the sort of thing I wanted to hear.
Young guys want to sit with the computer and do modeling. And I feel like sometimes I'm the last Mohican in doing experimental work.
This is an example of the Bernoulli effect, where the air rushing around each of these balls tries to hold it in a central place, which is because the air on each side has a different pressure from the center, and so this keeps pushing them in towards that central region.
One of the things I did when I was working in the research institutes was to develop a bubble chamber. I had the great advantage that there was a betatron in the accelerator building and a cyclotron, so I could command a beam to appear and then see what happened. So that made, I had the first pretty pictures of bubble tracks.
It was an ideal place for developing new instruments, new ideas, because you could discuss, if you had an idea to do something which went out of the mainstream line, like I did, you could find specialists in different fields that would help you.
It's a place where you can change your direction in the middle of your career and nobody complains as long as you do something else that's good.
The magnitude of the discoveries here, the best discoveries here, is not excellent, very good or excellent. It's historical in nature. It's literally changed the course of the history of science.
So in the design of the William Eckert Research Center, it's really all about light. The facades, bringing light deep into the building. In the design vision statement that the project steering committee put together, we actually pulled a quote from Louis Kahn, and he said, "All material in nature, the mountains and the streams and the air and we, are made of light which has been spent. And this crumpled mass called material casts a shadow, and the shadow belongs to light." So as you'll be able to walk down Ellis Avenue and experience the building in 2015, you'll see the interplay of light and shadow unlike any other building on campus.
The Research Institute's building was a fantastic place for science, but it's quite old now, and frankly, you know, its time has come in terms of the science, cutting-edge science done there, and so it's time for a new chapter, a new building. All right, friends, welcome. I'm Bob Pfefferman, Dean of the Physical Sciences, and on behalf of the University of Chicago, a warm welcome to all of you. This is a very happy occasion indeed for us because we're here to both pay tribute to the science that was done in the Research Institute's building by members of the Research Institutes, and also to look forward to a very bright future in a beautiful new building, the William Eckert Research Center. But let us start by recalling the nature of the history of this place, which is really quite something. I think most of you realize that the history here starts in World War II with something at the university called the Metallurgical Lab. That was the unit of the university responsible for being part of the Manhattan Project of the United States government. And that featured two items that were extremely compelling. One, it was one of the earliest very serious interdisciplinary efforts in science in the United States. You know, all universities now are very proud of interdisciplinarity, but at that time, that was something quite revolutionary. So that's a very important feature that we're still carrying on today. And second of all is simply the tremendous distinction of the scientists. The group of scientists at that time consisted of clearly some of the most illustrious thinkers in science of that day. And in order to carry forward the tremendous program of science at that laboratory, the president at that time, with the blessing of the Board of Trustees, Robert Maynard Hutchins, decided to propose two research institutes which have carried forward to today. They've been renamed in honor of some of the great scientists there. There, the Institute for Nuclear Studies, which is now known as the Enrico Fermi Institute, and the Institute for the Study of Metals, now known as the James Franck Institute. One problem I have here, and I don't have all day, I have to select some of the great scientists in order to just stroll back for a second and remember to just remind ourselves how great these scientists were. You know, so many Nobel Prizes, so little time. Just to select, so Enrico Fermi, of course, you know, we are literally feet away from the place where Fermi's experiment ushered in the nuclear age. Besides that, Chandrasekhar, someone I knew personally, at the age of 19, predicted black holes and is a candidate, in my opinion, for the greatest theoretical astrophysicist of the 20th century. Willard Libby's discovery of carbon dating, part of the history of the Enrico Fermi Institute and its implications for example, archaeology and paleontology, to mention two disciplines. Maria Goldbert-Mayer, Nobel Prize winner, proposing the nuclear shell model, one of the giants of nuclear physics of her time. In the James Franck Institute, which is the successor to the Institute for the Study of Metals, James Franck himself, a great giant of experimental atomic physics, doing some of the most important experiments of the time, confirming Bohr's model of the atom. And Yuan T. Lee, a pioneer of molecular beam spectroscopy, another Nobel Prize winner. But in terms of looking at the history, it's not just a question of those who have come and given us tremendous science, historical science, and passed along. We have a continuum of great scientists. And here again, forgive me, I have to choose a few examples. I would remind us, for example, in the Enrico Fermi Institute of Jim Cronin, who's here today, Nobel Prize for a CP violation. And I might add the creator, along with his colleagues, of the largest scale cosmic ray detector ever built in the Pierre Auger project. Yoichiro Nambu, our friend and colleague, who recently won a Nobel Prize for his discovery of spontaneous symmetry breaking. In the James Franck Institute, good examples, Leo Kadanoff, whose analysis of phase transitions, talk about interdisciplinary science, relates to urban planning, for example. He made connections between those two. Stuart Rice, I'm not sure exactly whether he's back from Israel now to collect the Wolf Prize, a pioneer of the field of organic materials. So you can see that this is not just something about the distant past, this is something that continues, and we're extremely proud of the grand tradition of science here, as well as the deep tradition of multidisciplinarity and the absence of giant walls in between the different disciplines of science. So the next thing I want to do is to call on colleagues who can reminisce and actually give you firsthand remembrances of their time here at the University of Chicago doing this great science. And my first colleague that I have the great pleasure of introducing is Professor Stephen Barry. Professor Barry has the appropriate title of the James Franck Distinguished Service Professor Emeritus in the Department of Chemistry and the James Franck Institute. So let me call on Steve. Thank you.
Thank you very much, Bob. Yes, I will tell you a little bit about my own coming here and about some of my feelings about this place. I must say that when I was a graduate student, one of my closest friends was, and still is, Stuart Rice. Stuart came to the University of Chicago in 1957, and at the same time, I went to Ann Arbor, to the University of Michigan. Being good friends, we invited Stuart to give a talk at Ann Arbor. Stuart invited me to come back and give a talk here at Chicago. Now, that was spring of 1958. Hyde Park was not a beautiful neighborhood in 1958 the way it is now. It was dirty, smoky, smelly, like the rest of Chicago. It was also a very rough, unstable neighborhood. It had just begun urban renewal, and you couldn't quite yet see the upturn. And we stayed with the Rices in what had been what was Morrill Cohen's apartment. Morrill was away on sabbatical. A house that Stuart used to refer to as the black hole of Drexel Street. We stayed in an interior bedroom, and you couldn't tell, looking out the window, whether it was day or night because the next house was so close. So as we drove back to Ann Arbor after our trip here, just as we were leaving Chicago, I said to my wife, "I will never live in that city." Well, by 1963, things had changed here somewhat, not yet nearly as much as they have now. And my view of the University of Chicago had changed very, very drastically. And when I was offered a position here, it took me less than a week to decide, yes, I do want to come. And it was one of the great positive decisions of my life. I feel that this university offers a kind of environment unlike any other I know. Partly, it's the university with the softest lines between different disciplines that I've ever experienced. For example, in about 1969, ecologist who was here then, Dan Jansen, David Curry from the law school, and I decided that we would like to give a course in environmental management. We were all very much involved in fighting air pollution. To do this, we had to find a slot. So we decided maybe the urban studies department was the right place. So I called the chairman of the urban studies program and said, these three people of us would like to give a course, and I expected him to say, I'll check with my department and let you know. No, he didn't do that at all. He said, oh, that's wonderful, I'll give you a number. And we had a course, which went on for years. And when David Curry went down to Springfield to head the Pollution Control Board, his place was taken by George Tolley from the economics department. And George and I taught the course together, and George and I still teach, now teach a course in energy and energy studies, energy policy. No problem at all to have this kind of cross-disciplinary interaction throughout this entire university. And I think that it shows itself in many ways. For example, people in different departments know each other well here in a way that I think no other university really has as an atmosphere. But there's one other aspect that I want to just comment about this university that I think makes it very special. And I think it makes it special in a way that is very positive for some people and not for others. The University of Chicago is a place where criticism is considered the way you make things better. And people who are uncomfortable with criticism are not comfortable at the University of Chicago. But people who find discussing things in a critical way, in an analytical way, find this the most stimulating possible kind of atmosphere. And I can't imagine being happier at any other university. Thank you.
This event is particularly meaningful to me because on the same year, in 1949, that was the time that I met Enrico Fermi for the first time. At that time, I was working on my dissertation at the University of Pavia, a famous university where Alessandro Volta had been teaching more than a century earlier. And I gave a presentation of my experiment to Enrico Fermi. He was quite impressed and complimented me and suggested to me that I should publish right away. And in fact I did, and that was my first publication. So here we go with the time capsule.
Professor Levi-Setti approaches with the time capsule. It's my pleasure to introduce my friend and colleague, Professor Roger Hildebrand, whose title is the Samuel Allison Distinguished Service Professor Emeritus in Physics. We talk about multidisciplinary astronomy and astrophysics, the Enrico Fermi Institute. And I might point out to you that Samuel Allison was the first director of the Enrico Fermi Institute. Roger?
Well, Ricardo and I bring to this ceremony the qualification that we're both old enough to remember this building when it was new. Now, I cannot tell a lie. The truth is we've had a dry run at pulling things out of the box. And we know that there's no scientific forecasts in this box except some mistaken generalities about what the research institutes are supposed to do. And yet there are some things, very commonplace things in the box that have become intriguing simply because they've been hiding in the Cornerstone for decades. So we'll begin with those. So Ricardo, if you'd pull out the first thing. This is the announcement of the colleges and the divisions, so this will tell you what courses you could take then. Things like equitation and hippology. This is the telephone directory for the University of Chicago, 1948. Now, I should have brought today's telephone directory. It's 2 volumes and much bigger.
It had the names of the wives.
This is a road map that you could pick up at your Mobil oil gas station while someone pumped your gas, checked the oil level, filled your radiator, and cleaned your windshield. Now we come to a bundle of timetables. This one from Capital Airlines. You could get a reserved seat on their flight from Chicago's Municipal Airport to Washington for, let me see, it's $47.59. This one from TWA offers you a flight to San Francisco for $113.75. You could board at 8:40 a.m. Central Time, and after 5 stops, arrive in San Francisco at 6:25 p.m. But along the way, a stewardess would serve you a hot meal. Now, the next thing, we come directly here to Ellis Avenue. This is the architect's rendering of the Research Institute's building. Now, apparently taken by somebody standing in the middle of Stagg Field, near the future site of Regenstein Library, but with the west stands, which were then still standing, made invisible. The building cost $4.8 million. And as far as our accounting office can tell me, the money came entirely from unrestricted endowment and unrestricted reserves. There were no grants and no gifts. But after all, who would want his name attached to this? we should never underestimate the side benefits of having a real donor. The next document describes the 3 institutes to be housed in the building. The Institute for the Study of Metals, the Institute for Nuclear Studies, and the Institute for Radiobiology and Biophysics. But in the document, the fields of research were abbreviated to nucleonics, metals, and biophysics. But nucleonics turned out to be a lot of non-nuclear things that we'll come to in a few minutes. Metals was a lot of non-metallic things. Liquid helium and granular solids. And a lot of the best biophysics was initiated in the nucleonics part of the building. Let's see now. This is atomic research, the new frontier of industry. It was a pitch to industrial sponsors who were asked to give $50,000 a year for the privilege of easy access to our classrooms, our faculty, and our seminars. But alas, a sponsor who sat mystified in a seminar, say on a new quantum number, found himself no closer to the new frontier of industry. So this relic is all that remains of the Institute of nothing else? Well, somebody stole it. It's a 1927 Buffalo nickel. And I don't know what to say. Oh, this is serious. We've got the at any rate, that cleans out these trove of artifacts. And so it's time to ask the dean to talk about the future.
Thank you very much, gentlemen. Well, we do want to look forward to the future. And I think it's going to be a very exciting future indeed. And before remarking about the science, I want to remark about something very connected to science, which is the new building, the William Eckert Research Center that we're looking forward to. And although he couldn't be here today, I do want to thank my very close friend, William Eckert. Roger talked about a donor. This will be a beautiful building. And through his generosity, we have the possibility of such a fine structure which will allow great science. Not just something of beauty, and it will be beautiful, but also something whose structure, whose infrastructure will allow cutting-edge science. That's extremely important for us. Something about Bill, he is, you should know, he is a close friend of mine. He's a distinguished alumnus of the mathematics department of the university, a legendary figure in the world of finance, a very brilliant scholar, someone with hobbies that I think you don't see too often as hobbies. Quantum mechanics, for example, and the philosophy of time. He also has a bit of a sense of humor. I asked him recently, I pointed out to him that I considered him a Renaissance man. When you talk to him, it's not just these two, quote, hobbies that he has. He seems to just know everything. And his remark was, "I'm not that old." So we thank him. Tremendous friend, not just to me personally, but to the university. Thank you. In terms of looking forward to the science, this is going to be very exciting indeed. The inhabitants of the new building, some of the very great units of the university, the Astronomy and Astrophysics Department, the Kavli Institute for Cosmological Physics, additional parts of both the EFI and JFI, and the very exciting new venture of the university into engineering, something that really is, talk about historic. The combination of the power of science at this university with this new effort in engineering is going to be quite something, I'm very certain. The questions that we will attack, things like what is dark energy, for example, dark matter, is there life elsewhere in the universe, applications of deep science, things out of the combination of science and engineering, energy, questions of solving the energy crisis, personal medicine, adjusted to DNA and so on. Very, very exciting time for this kind of science to be pursued, and especially in a cutting-edge structure that we're going to dedicate. Again, I'd remind you that the multidisciplinarity is a key, and it remains a key. The history that is so strong that we're so proud of in celebrating today is something that is going to be carried on in the future, and that we're very grateful for the scientists, and very excited about. So thank you very much for participating in this, our friends and our colleagues. And I believe that we have on display at this table some of the artifacts present in this time capsule. And I might add that I fully intend to ask for the construction of a time capsule in the new building in the Eckert Center, and probably beyond time schedules and airplane schedules, things like, and catalogs of the university, fundamental predictions of science of the next 50 or 60 years. So thank you very much, friends. Please be my guest at inspecting these items. Thank you.